Okay, students, so in laboratories, it is common that we uh, dilute solutions. So we take a concentrated solution and we will take so much volume of that solution and then dilute it to get a concentration of a lower concentration. And so we call this dilution. And so with dilutions, we use the equation M1 times V1 equals to M2 times V2, right? Remember that the molarity times the volume in liters gives us the number of moles of solute, right? So the number of moles of solute for M1 V1 is going to equal to the number of moles of solute for M2 V2. Because after all, we are just diluting that number of moles of solute. So the number of moles of solute isn't changing. It's the volume that's changing between um, one solution to another solution that's being diluted. Okay, so in this problem, it says what volume of a 12.0 molar concentration of HCl is required to prepare 2.5 liter of a 0.100 molar concentration of HCl solution. So think of M1 and V1 as your original or more concentrated solution, and M2V2 as your dilute solution. Okay, and so what we need is the number of milliliters or liters from this 12.0 molar concentration of HCl that would ultimately give us the 0.100 molar concentration of HCl that's diluted to a volume of 2.5 liters. Okay, so we're looking for V1. So we'll divide both sides of the equation by M1. And so what that will give us is V1 equals to M2 V2 divided by M1. And so we'll plug in here. So we have 0.100 molar concentration. And then we'll multiply that by the volume of that solution, which is 2.5 liters. And then we're going to divide by M1, which is the 12.0 molar concentration of HCl. And so molarities here cancel, leaves me with liters, all right, which is the volume of the solution. And so we get 0.0208 liters, okay? So sig figs here, we need to report it to 2 sig figs, so that would be the correct number of sig figs would be 0.021 liters, or we just report that in milliliters, so we'll just simply move the decimal place 1, 2, 3, and that would give us 21 milliliters. Okay, so we would need approximately 21 milliliters of the 12.0 molar HCl solution and then we would add that to a volumetric flask, and then that would be 2.5 liters, and then we would dilute to the mark with water, and that would give us the 0.100 molar concentration solution of HCl. So again, the dilution equation is quite useful. We use this quite a bit in lab to prepare solutions from stock solutions. Okay, let's apply solution stoichiometry to a chemical reaction. So in this chemical reaction, this is a precipitation reaction where we have two solutions that ultimately yield copper 2 phosphate, which is our precipitate. So it crashes out of solution. So it's a solid that crashes out of solution. So we have 2 moles of sodium phosphate reacting with 3 moles of copper 2 chloride. And again, that yields copper 2 phosphate precipitate plus 6 moles of sodium chloride, which will remain in solution. All right, so the chemical equation is balanced. We have 6 sodiums here, and we have 3 coppers. We have 3 coppers here, and we have 8 oxygens, and we have 8 oxygens here. And we have 2 phosphorus here, and we have 2 phosphorus right here. So our chemical equation is balanced. We got 6 chlorides, 6 chlorides. So everything, our atom count looks spot on. The chemical equation is balanced. So now, given the information here, it says what volume of a 0.175 molar concentration of sodium phosphate. So we'll just write that in moles per liter. Okay, we'll just express the molarity in moles per liter. Is necessary to completely react with, let's see here, 90. We have 94 point, I'm sorry, that's not 94, that's 95. 95, okay. 95.4 milliliters of copper 2 chloride at a concentration of 0.102 molar. Okay, so I'll just go ahead and I'll write this in moles per liter too. All right, so what we need to do, guys, is if we could get in moles of copper 2 chloride, that would allow us to utilize the mole ratio to then get in moles of sodium phosphate. Okay, so what we need to do then, if we have 95.4 mils of this copper 2 chloride, so remember molarity is equal to the number of moles, in this case of copper 2 chloride, divided by the number of liters of copper 2 chloride solution, right? Copper 2 chloride solution. Yeah. So let's rearrange this, all right, where we can solve for the number of moles of copper 2 chloride, all right, which is simply going to equal to the molarity of the copper 2 chloride solution, which is 0.102 moles per liter of copper 2 chloride solution, and we'll simply multiply that molarity by the volume of the solution. But wait, this is in milliliters. Uh-oh, how do I convert this to liters? I am going to move the decimal point here, 1, 2, 3 places to the left. So that'll give me 0.0954 liters of copper 2 chloride solution. So I'll put that here, 0.0954 liters of copper 2 chloride solution. So liters cancel. And what does that give me? Well, that's going to give me 0.00973 moles of copper 2 chloride. That's the number of moles of copper 2 chloride solute I have in my 95.4 ml solution. All right. So that's step 1 in this process. So now we'll go to step 2, not 3, 2 here. All right. So in step 2, now I'm going to calculate for the number of moles of sodium phosphate. Yeah. So that is simply going to equal to, well, we start with the number of moles of copper 2 chloride, which is 0.0099973 moles. Yeah. All right. Of copper 2 chloride. Okay. So we utilize our mole ratio here. Yeah, we're going to make use of that mole ratio, guys. That's why we got to make sure that chemical equation is balanced, right? So we have for 3 moles of copper 2 chloride, we have 2 moles of sodium phosphate. Okay. So it's a 2 to 3 mole ratio. Okay. So we utilize the mole ratio to go from moles of copper 2 chloride to moles of sodium phosphate. So when we carry out this calculation, right, we get 0.00649 moles of sodium phosphate. Alrighty. Alright, so now that we're in moles of sodium phosphate, check this out, guys. If I'm given the molarity of a substance and I'm given the moles of that substance, I can calculate the volume in liters of that substance, right? Remember we said molarity is equal to number of moles, in this case, let me see, number of moles of sodium phosphate all right, divided by the liters, or number of liters, I should say, number of liters of that solution, right? Which is ultimately what we're trying to solve for, right? So they give us the molarity of the sodium phosphate solution. So if we want to get at the number of liters of sodium phosphate solution, we simply will take the number of moles of our sodium phosphate solution and we'll divide that by the molarity of the solution, right? The molarity of the sodium phosphate solution. Okay, so let's do that. So the number of liters here is going to equal to, or the number of liters of solution is going to equal to, well, we have 0.00649 moles of sodium phosphate. And we're going to divide that by the molarity of the sodium phosphate solution, which is 0.175 moles per liter of solution. So that liter will flip up into the numerator. So our moles cancel, and that leaves us with liters of solution. Okay? So what that ends up equaling, what we get here is 0.0371 liters. Okay. Now, if we want to convert that to milliliters, then that will be 37.1 milliliters. So there you have it. Okay. A lot going on here. Okay. But the first step is getting in moles of your solute of the in this case of the copper 2 chloride, and then once you're in moles of that, utilize the mole ratio to get in moles of the other reactant, which in this case is sodium phosphate. And then once we have the moles of sodium phosphate, we simply divide that number of moles by the molarity of the sodium phosphate solution, and that will give us the volume of the solution in liters, okay, that would be necessary to completely react with copper 2 chloride solution. All right. So I hope these videos have been helpful for you, and as always, happy studies.